Hello and welcome to this math tutorial. Now let's find the value of this expression. We have 6 plus logarithm to base 3 over 2, okay, of the product of 1 over 3 root 2 and this what I call nested expression, okay. Now in this nested expression we can see that we have the same expression embedded in the what? In the nested expression, that is 4 minus 1 over 3 root 2. We have another one again, 4 minus 1 over 3 root 2, like that. So we have a nested expression. So to be able to find the value, okay, of this expression, so we need to first, work with the nested expression. So to do that, let me write the question again. Okay, we're given 6 plus logarithm to base 3 over 2 of the product of 3 root 2 radical 4 minus 1 over 3 root 2, then radical 4 minus 1 over 3 root 2. Okay, radical 4 minus 1 over 3 root 2, like that. So now, this is where I can now represent this expression with a letter from the alphabet. So let me choose a letter to represent this. So I can say let k equals to radical 4 minus 1 over 3 root 2, okay, of radical 4 minus 1 over 3 root 2 of radical 4 minus 1 over 3 root 2, like that. All right, so having represent this expression with letter K. Now we can also see that the same expression, that is this same expression, we can also see it in the what? In the same expression. That is, we can see it embedded in this expression. We represented this expression with letter K, and the same expression is still embedded in the expression, like we can see it here. So which means, having represented this with letter K, then I'm going to replace this with what? Letter K as well. So this will become K equals to radical 4 minus 1 over 3 root 2, then K, because we have the same expression. That is it. When we have a particular expression embedded within the given expression, and this is the expression in this case is 4 minus 1 over 3 root 2. All right, so this is where we can now square both sides. So squaring both sides, we can now have k squared equals to the square of root 4 minus 1 over 3 root 2k raised to the power of 2. So this will be k squared equals to 4 minus 1 over 3 root 2 times k. All right, now to be able to write this as a standard quadratic equation, so I'm going to multiply this equation by 3 root 2. Okay, multiplying the equation, this equation, okay, the equation in k, okay, by 3 root 2. So this is the equation in k. All right, so we're going to have, so let me write it here. We're going to have k squared equals to 4 minus 1 over 3 root 2 multiplied by k. So this will be multiplied by 3 root 2. So when this equation is multiplied by 3 root 2, on the left hand side, we're going to have 3 root 2 k squared, because 3 root 2 times k squared, that will be 3 root 2 k squared. Okay, 3 root 2 multiplied by 4, that will be 4 times 3 root 2, that will be 12 root 2. Then 3 root 2 multiplied by minus 1 over 3 root 2 times k. This is going to be minus k. Now, I can write this as a standard quadratic equation, and this will be 3 root 2 k squared plus k minus 12 root 2 equals to 0. All right, so now we can now solve for the value of k. Now to solve for the value of k, now I think let me use this method. Okay, now we know from here that the product of roots for this equation will be whatever we get from the product of the leading coefficient in this equation and the constant term. And we know that the leading coefficient is 3 root 2, while the constant term is negative 12 root 2. So 3 times negative 12, that will be minus 36, multiplied by root 2 times root 2, that's 2. 2 times negative 36, that will be minus 72. So we need two factors of 72 that when multiplied together will give us, when multiplied together will give us negative 72, and when added together will give us plus 1. That will give us 1, and that will be 9 and 8. So this is 3 root 2k squared plus 9k minus 8k, okay, minus 12 root 2 equals to 0. Okay, so then let's factor out the common factor. In this case, 3k is common, okay, because 3 root 2k squared divided by 3k, that will be root 2k, plus 9k divided by 3k, that will be plus 3. Now, in this case, now 8 is the same thing as 4 root 2 multiplied by root 2, okay, because root 2 times root 2, that's 2. 2 times 4, that will be 8, because of course we know that that's in the second parenthesis we must have the same, the same element. So in this case, this would be, so which means this is same thing as negative 4 root 2, okay, negative 4 root 2, okay, 8k minus 8k divided by negative 4 root 2, that will give us root 2k, because minus 4 root 2 times root 2k, that will be negative 8k. Now, minus 12 root 2 divided by minus 4 root 2, this will be plus 3, and this is equals to 0. All right, so now we have 3k minus 4 root 2, okay, multiplied by 2 root 2k plus 3 equals to 0. All right, so from here, we have our 3k minus 4 root 2 equals to 0, or root 2k plus 3 equals to 0. Now, let's solve for k in this case. So first, we know that 3k will be equals to 4 root 2. Then if we divide both sides by 3, now k will be 4 root 2 over 3. Then in this case, to solve for k, all right, we have root 2k to be equals to minus 3, so that k can be equals to negative 3 over root 2. This will not be a solution in this case. It won't work, okay? All right, so we can only what? We can only consider the real value of k, okay? Positive, okay? Positive solution in this case. All right, so now we just found the value of k. Now let's go back to what we have here, okay? Remember, I represented this expression with letter k, okay? So I'm going to what? I'm going to replace this expression with letter k in what we have here in the logarithm. So I have, of course, so from our 6 plus log 3 to base 2, from here, okay, from here, now we have product of 1 over 3 root 2. Remember, this expression, we represented this expression with what? Letter k. So this will be multiplied by k. Now, the value of k we got here is what? 4 root 2 over 3. So this will be 6 plus logarithm to base 3 over 2, okay, of 1 over 3 root 2, okay, multiplied by 4 root 2 over 3. Okay, so this will cancel this, so we'll be left with 4 times 1, that will be 4. So this is logarithm to base 3 over 2 of 4 over 9. Now let's look at this log part here. What we can see here is when we write the numerator and denominator in the argument, okay, as a power of 2, okay, when we, like, for example, now for 4, we know that 4 can be written in terms of base 2, as 2 raised to the power of 2, and 3 can be written in terms of base 3 as 3 raised to the power of 2. But the base of the log is 3 over 2. What I'm saying here is that in this case we have 6 plus logarithm to base 3 over 2 of 2 over 3 raised to the power of 2, which is same thing as 4 over 9. Okay, now if I apply the property, the nth logarithm of the nth power of p to base a, which is equals to the product of n and log p to base a in this case, then this will be 6 plus 2 logarithm to base 3 over 2 of 2 over 2. Okay, now I can flip this, because if I write this to be if I write this to be 1 over 3 over 2, okay, that is reciprocal of this will be 1 over 3 over 2, okay, which is when we write 2 log 3 over 2 raised to the power of minus 1 to base 3 over 2. Then I will again take the power, okay, multiply this power by the, so in this case this is going to be 6 plus 2 times minus 1, then logarithm to base 3 over 2 of 3 over 2. All right, so in this case 2 times minus 1, that will be minus 2. So this is 6 minus 2. Then we have logarithm to base 3 over 2 of 3 over 2, which is equals to 1, and that will be 6 minus 2, and 6 minus 2 will be equals to 4. Let's not forget that when the argument and the base of a log are the same, then that will be equals to 1. So which means logarithm to base 3 over 2 of 3 over 2 is equals to 1. So 1 multiplied by minus 2, that's minus 2. So 6 minus 2. And the value of this expression is equals to 4. I'll see you in the next video. Bye-bye.